Alright, welcome to a video on the chain rule for differentiation. All I could say is that this is the end-all, the be-all video for differentiation. The chain rule is used for the really tough problems, and these are the problems that are going to separate the people that pose, that think they could find derivatives, between people that really know how to find derivatives. So the chain rule is the trickiest of all the rules, but hopefully with my great explanations, you will be a pro at it by the end of this video. But this video is long, and there are lots of examples, because this is a tougher rule, so we have to practice a lot with it. Alright, so the chain rule deals with composite functions. Remember, those are functions that are composed of other functions. And it actually adds a lot of versatility to all of the rules that we have already learned so far. So almost all the rules we've learned so far, we could use the chain rule with. So here's some examples. On the left-hand side here, these cannot use the chain rule. These are easy, right? The derivative is 2x, the derivative is cosine, the derivative is 3, the derivative is 1 plus secant squared. I mean, these are easy derivatives that involve simple rules. But on the right side here, we have the chain rule. See, these are functions within a function. So we got a square root, and then inside of that square root, we have another function, x squared plus 1. That's going to require the chain rule. Here's another one. We have sine. We have a sine function, but inside of the sine function, we have a function 6x. Here is a fifth degree, right? A function raised to a power. So we have a function, 3x plus 2, inside of a fifth degree function. And then here's another one where we have x plus tangent x squared, right? So we have this function x squared inside of this tangent function. So to solve any of these tougher problems, we definitely need this new and very powerful, very versatile chain rule. All right, so let's get right down to it. What is the chain rule? The chain rule says this: if you have y, which equals a function composed of u, if that function is differentiable, and you also have u, which equals another function g of x, that function is also differentiable, then, basically I could rewrite, like if u is g of x, so if u is itself a function that is put into another function, f, then we get this composite function, right? We get f composed of g. This is a composite function, which we learned a long time ago. Well, this is differentiable, and here's how you do it. So to find the derivative of a composite function, is this rule a little bit tricky? I told you it's tricky. You have to first find the derivative of f with g inside of it. So you don't do anything with g, but you do find the derivative of f, and then you multiply that by the derivative of g. Now, at this point, you're like shaking your head, opening your eyes. You're like, what is this? Again, I told you it's a tricky rule, but you just got to get used to it. You're going to find the derivative of f composed of g. Then you're going to multiply that by the derivative of g. So it can definitely be a little bit tricky. So let me try to make this easier on you. Let's relearn the power rule with the chain rule. So if you remember, the power rule says if you have a function x to the n, the derivative is just drop down the power, and your new power on that x is 1 less than the old power. Easy. But what if the base is u? Like, what if the base is not just x, it's itself an own function? So here's how the chain rule works, right? So the first thing you got to do is you find the derivative of that function. So again, to find the derivative, the n falls down in front, leave u alone, and your new power is n minus 1. But then, if what's inside of that function is itself a function, you then have to multiply by the derivative of that function. To be honest, we are already kind of doing that with the chain rule, right? We have y equals x to the n. The rule says to drop down the power. New power is the old power minus 1. And then what I'm adding now is you have to multiply by the derivative of the base. Well, what's the derivative of x? 1. Well, when you multiply by 1, it doesn't change anything. That's why I haven't been teaching it that way. But if that base is now something other than just a simple x, you just have to multiply by the derivative of that. All right, let's also apply the chain rule to our trig functions. For example, we have learned for a long time now that the derivative of sine is cosine. Easy, right? But what if what's inside of that sine is more than just an x. It's itself a function. So then what you have to do is you find the derivative of sine, which is cosine of u, and then you just have to multiply by the derivative of u. So it's the same idea, right? Find the derivative of the overall function, right? The overall function is sine. The derivative of sine is cosine. But then you have to multiply by the derivative of what's inside that function. That's the chain rule. Multiply by the, start with the derivative of the overall function and then multiply by the derivative of the inside. So here's another one, cosine of u. The derivative of cosine is negative sine of u. And then we have to multiply by what the derivative of u is. Again, we've already been using this when we say, hey, y equals sine of x. And we say, all right, the derivative is, well, the derivative of sine is cosine of x. But then technically, to use the chain rule, you have to multiply by the derivative of the inside. But again, that's just one. But what I'm now saying is, what if the inside of that is something a little bit more? Then you have to extend with the chain rule. All right. Regardless of what you think about the chain rule, easy or hard, trust me, it will get easier with practice. The actual application of the chain rule is very simple once you start using it. But simplifying the derivative after the chain rule has been used can always be tough. And again, I'm going to be honest with you, that requires algebra. So that's going to be the hardest parts for some of you. All right, let's just dive into a couple examples right away here. All right, so I have a function x squared plus 1 inside of a square root. The first thing I'm going to do, involving no derivatives, is I'm just going to rewrite that as a power. So now I'm just going to apply the power rule with the chain rules. Check this out. You're going to love it. The 1/2 falls down in front. Leave the inside alone. The new power is 1 less than the old power, so that's negative 1/2. But then wait a minute. Now the chain rule says I now have to multiply by the derivative of the inside, which is 2x. And that's it. Yes, that's it. I'm done. That's the derivative. Now, of course, like I said, the cleanup work is the hardest part. This right here is a negative exponent, which I don't like. So I'm going to leave the 1 times the 2x on top. And on the bottom, I have the 2. And now I'm going to bring the x squared plus 1 to the bottom, where it can become a positive 1/2. And I'm going to further clean this up, because obviously 1 times 2 is 2. That 2 and this 2 can reduce. So I get x over x squared plus 1 to the 1/2. So there is my final derivative. Pretty easy. All right, let's try this one out. All right, the derivative. Well, again, I remember the derivative of sine is cosine. So the derivative of sine of 6x is cosine of 6x. But, the chain rule says now you have to multiply by the derivative of the inside, which is 6. So my final cleanup answer is 6 times cosine of 6x. Easy. Like I said to you guys, most people walk away thinking the chain rule is not that bad. It's simplifying that gets tricky. All right, let's try this one. All right, I'm going to use the power rule with the chain rule. 5 falls down in front. Leave the inside completely alone. New power is 1 less than my old power. But. Chain rule says I now have to multiply by the derivative of the inside, which is 3. Well, this now turns out to be a really easy problem. I get 15 times 3x plus 2 to the 4th. Done. Simple. All right, let's try this one out. The derivative. Now, I'm going to need a lot here. I'm going to need the addition rule. The addition rule says find the derivative of the first part, add the derivative of the second part. Well, that's easy. All right, the derivative of x is 1 plus. All right, what's the derivative of tangent? Well, the derivative of tangent squared, or the derivative of tangent of x squared would be secant of x squared. But wait a minute. I then have to multiply by the derivative of the inside, which is a 2x. So now that I clean this up, I get 1 plus 2x times secant squared. Oh, that should be a secant squared right there. I'm very sorry about that. Secant squared of x squared. Now the reason why I moved the 2x to the front is I don't want anybody to think that it's inside of the secant, right? You could also rewrite this as 1 plus 2x times secant of x squared all squared, right? You could put the square right here, or you can move it to the outside. So again, that's how we use the chain rule. Pretty easy. All right, let's just keep working here. Let's just keep working. All right, again, oftentimes you do have to rewrite, so that way you could use the power rule. So I'm going to rewrite this as tangent of x squared. Technically, those are both the exact same thing, but doing this is going to help making the rule a little bit easier. So let's see here. The derivative, the 2 falls down in front, leave the inside alone. The new power is 1 less than my old power, so it's going to be a power of 1. But now I got to times it by the derivative of the inside. The derivative of tangent is secant squared. All right, so I get a final cleaned up answer. Now, tangent to the first is just tangent, so I get 2 times tangent of x times secant squared of x. There's my nice final answer. Pretty easy. All right, let's try this one right here. Another really easy one, right? I told you, using the rule is going to get easy once you use it. All right, power rule, 3 falls down in front. Everything inside stays the same. New power is 1 less than the old power. But chain rule says I now have to multiply by the derivative of the inside, which is going to be 3 minus 4x. So, there's a couple of things you could do. First, because this is being squared, you cannot distribute the 3. But multiplication order doesn't matter, so I guess I could leave the 3 in the front. I could bring the 3 minus 4x to the front, multiplied by 3x minus 2x squared, all squared. Now, I know that that's not the prettiest answer, but that's not a terrible final answer right there. Obviously, I could square this back part out and then do a whole bunch of distribution and combining of like terms, but you know what? I'm pretty content with that as my final answer. All right, let's start to slowly dive into some trickier ones. I'm going to change to yellow here for some of these trickier problems. All right, again, sometimes it's worth it to first rewrite the function. This is x squared minus 1 to the 2/3 power. Again, I have a third root and a second power, so that's a 2/3. All right, now, oh my goodness, all I got to do is use the power rule. 2/3 falls down in front. Inside stays the same. The old power is 1 less than my old power, right? So I'm going to do 2/3 minus 3/3, which is going to be negative 1/3. Times, again, this is where the chain rule comes in. Don't forget to multiply by the derivative of the inside, 2x. You can even throw it in parentheses if you want. All right, so now again starts that cleanup work. Let's see here. I don't like the negative exponents. That's going to need to move. So on top, I have a 2 times a 2x. This guy's on top. This guy's on top. Again, remember, on the side or on the top, same thing. And then in my denominator, I'm going to have the 3 alongside of the x squared minus 1 to the 1/3 power. So again, I could clean this up by saying 4x on top, 3 times x squared minus 1 to the 1/3 power in the denominator. There's my final derivative. And of course, you don't have to, but if you wanted to, you could rewrite that as a cube root of x squared minus 1 if you wanted to. I don't care. I don't mind fraction exponents. I just don't want them negative. All right, and we're plugging along here. All right, now things are going to start to pick up, because now what you're going to find me doing is using the quotient or product rule with the chain rule inside. So yeah, things are going to start to get tricky here. All right, here we go. I have a quotient. I have a numerator, I have a denominator. I'm going to need the quotient rule. Quotient rule says start with the bottom, leave it completely alone, multiply that by the derivative of the top, which is 0. Ooh, I'm already liking that. Minus, now I'm going to take the top, and I'm going to multiply by the derivative of the bottom. But to find the derivative of the bottom, I need the chain rule. So the 2 is going to fall down in front. 2x minus 3 stays the same, raised to the first power. 2 minus 1 is 1. But I got multiplied by the derivative of the inside, which is just 2. So I got a whole lot going on there. And then all divided by the denominator, all squared. So I got 2x minus 3 squared. All right, and this one actually doesn't take too long to clean up. Obviously, multiplying by 0 wipes all of this out, which I love. All right, let's see here. I have a negative 7 times 2, which is 14, times this other 2, which is a 28. But then this negative right here is going to make that a positive 28, times 2x minus 3. Again, let me make sure everyone understands where that comes from. Negative 7 times 2 is 14. Order of multiplication doesn't matter, so I'm going to jump and multiply by this 2. That's where I'm getting the 28 from, but it becomes positive because of the double negative. And then I'm going to, watch this, don't distribute. Do not distribute that 28. You're going to see why here in 1 second. In the denominator, I have 2x minus 3 to the 4th, because I got a power to a power. You multiply those. 2 times 2 is 4. But check this out. This is a 2x minus 3 to the 1st. On the bottom, I have 2x minus 3 to the 4th. So this one will cancel with one of them on the bottom, leaving me 3 behind. So final answer to this derivative is 28 divided by 2x minus 3 cubed. Again, there was one 2x minus 3 on the top, 4 on the bottom, so one of them canceled. So that really wasn't too bad. Again, I'm telling you guys, you're going to love the chain rule. It's not that hard. It's the cleanup that makes it a little bit tougher. All right, let's dive into this one. I'm going to need the product rule because I have a function times another function, which I am going to rewrite as a 1/2 power. That's going to make my life a little bit easier here. All right, let's find the derivative. Product rule says, leave the first guy alone. Multiply by the derivative of the back. All right, so here I go. I need the chain rule for that, right? 1/2 falls down in front. Leave the inside alone. New power is negative 1/2 times the derivative of the inside is negative 2x. Again, so I got an awful lot going on there. So I left the first guy alone, and then I had to find the derivative of the back. And the derivative of the back took the chain rule. So a lot of work going on there. Plus, now I'm going to keep going with the product rule. This time I'm going to leave the back alone, 1 minus x squared to the 1/2. And I'm going to multiply by the derivative of the front, which is a nice, simple 2x. All right, guys, now I'm not going to lie. A problem like this involves a lot of really hard cleanup work. All right, let's just start by trying to get things looking a little bit nicer here. So let's see here. On top, the first thing I notice I have is a 1 minus x squared to the negative 1/2. Everything else I can multiply. So I got an x squared times a 1/2 times a negative 2x. Okay, well the x squared times x will make an x cubed. And then the negative 2 times the half just makes a negative. So I got negative x cubed times 1 minus x squared to the negative 1/2. All right, so this entire front part, right? Sorry, it's getting messy here. Did simplify fairly nice. The 1 minus x squared to the negative 1/2. Now, again, that's a power, so I can't really distribute into that or anything like that. But everything else I could clean up. Again, the 1/2 times negative 2 is negative 1. The x squared times x is the x cubed. All right, and in the back, again, there's really nothing I could do. I am going to move the 2x to the front, and then the 1 minus x squared is to the positive 1/2. All right, this next step, that first step isn't too bad. Let me clean this up here. Kind of messy to me. This next step is going to be the tricky part. This is the part that's a little bit harder for some kids to process. So let me change colors here. All right, so what I'm going to do is I'm going to do some factoring. I have two terms. I have this first term, kind of ugly, I know, and this back term, which is also kind of ugly, but not too bad. What's common between these two terms? Well, first, there's an x. There is an x that's common, right? This guy's got x cubed, this guy's got x to the first, so I can factor out an x. But I could also factor out a 1 minus x squared to the negative 1/2. All right, I can do that. Watch, you'll see why. Now, what happens when I factor this out? All right, so this is going to become a negative x squared because I took the x away. And I took the 1 minus x squared to the negative 1/2 all out. So that's completely gone. So that's just multiplied by 1. Right? Again, the negative x cubed had an x taken away, so it's negative x squared. The 1 minus x squared to negative 1/2 all got taken away. Plus, now what's back here? Well, I'm going to have a 2. I'm going to have a 2. The x got taken away. And, all right, so I had 1 minus x squared to the 1/2. But I took away a negative 1/2. So you subtract, right? You had a 1/2. You took away a 1/2. So that's going to result in a 1. Because we have 1/2 take away a negative 1/2, right? Remember, right? You know, if you're like, what is he doing? Just think about something as simple as this. X to the 5th plus x squared. I could factor out an x squared, and 5 minus 2 leaves me with x cubed plus 1. 5 minus what I took out. Well, I'm doing the same thing, right? I took out a negative 1/2. So if I have a 1/2 and I take away a negative 1/2, you really end up adding 1/2 plus 1/2, which turns into 1. So I end up with 1 minus x squared to the 1. All right? Now, I always tell kids, if you don't believe me on any of this, just redistribute. X times negative x squared is negative x cubed, times the 1 gets the 1 minus x squared, the negative 1/2, so I'm right back to here. And if I distribute to the back, I have x times 2, which is the 2x, and then 1 minus x squared to the negative 1/2 times 1 minus x squared to the positive 1/2. What do? You add your exponents, and a negative 1/2 plus a 1 is back to a positive 1/2. So you do get this. Now again, I told you, this is the trickiest part. A lot of kids do get this wrong. All right, so at this point, I could just do a whole bunch more cleanup work. So I have x times 1 minus x squared to the negative 1/2 times, back here, I'm going to do a little bit of cleaning up here, right? Let me grab a different color so you can see my cleanup work here. So this is negative x squared. I wanted to grab a different color. Negative x squared plus distributing now, because now there's a 1 here, you can distribute, right? 2 times 1 is 2. 2 times negative x squared is negative 2x squared. So now I can combine those like terms. Now it's a negative 3x squared plus 2. All right, so there's one more thing. I could do one more cleanup work to get a nice final answer here, and that is I don't like negative exponents. That's going to move to the bottom. So on top I have an x times negative 3x squared plus 2. And on the bottom I have a 1 minus x squared all to the positive 1/2 now. And boy, oh boy, that is definitely a tricky problem. And again, if you really wanted to, you could not distribute that x across the top. You can or you cannot. It's up to you. I don't care. That's a tough problem, but here's what I want to encourage you with. Using the actual product and chain rule was very simple. I was done with that in that first step. Then involves all the cleanup work. And cleaning up with negative exponents, negative fractional exponents, obviously is going to make this problem even harder. But I do arrive at a fairly decent looking final answer. Now I will say this. Remember, we originally learned how to do derivatives with limits. This you would never ever want to do with limits. So trust me, as hard and difficult as the cleanup work can be on these, honestly guys, you're not going to get it done in the one problem. You need to practice. All right, let's try a couple more here. Again, I told you this is a little bit longer video, but this is a tough rule. We got to really practice this rule here. All right, let's go here. We're going to need the quotient rule, but before I use the quotient rule, I do want to clean up that denominator because I want to treat that as x squared plus 4 to the 1/3. That's going to allow it to be a little bit easier on me to use the chain rule when I need to. All right, here we go. The derivative. I'm going to need the quotient rule here because I have a numerator and denominator. So quotient rule says leave the bottom alone. So there it is. Times it by the derivative of the top. Oh, that was simple. All right, minus. Now we're going to leave the top alone, and we're going to multiply by the derivative of the bottom, and yep, here comes the chain rule. 1/3 falls down in front. New power is 1/3 minus 1, which is going to be negative 2/3, times the derivative of the inside, which is 2x. And again, all, this is going to take me a while here, all, there's so much, all divided by x squared plus 4 to the 1/3, all squared. That's the quotient rule. All right, now starts my long journey of cleanup. All right, at least this first part is easy, right? Just multiply by 1, you get x squared plus 4 to the 1/3. Easy. Minus, all right, let's see here. I got x times 2x times 1/3. That's going to be 2/3 x squared times x squared minus, or excuse me, x squared plus 4 all to negative 2/3. All divided by x squared plus 4 to the 2/3. Again, a power to a power says you multiply them. All right, so kind of sit back and take a look at what I've done so far. It's kind of ugly, not going to lie, but I have followed the quotient rule and the chain rule within, and for the most part it wasn't too bad. Make sure you understand where the 2/3 came from. That's this 1/3 times 2, that's the 2/3, and then x times this x is the x squared. All right, now I got to ask myself, from the numerator, what the heck can I factor out? Well, let's take a look. There's an awful lot up there. What can I factor out? Okay, well, between this term and this term, let's see here. I could factor out the smallest power, right? So I could take x squared plus 4 to the 2/3. I could factor that out. Okay? Because again, remember, you could always take out the smallest amount. You know what I mean? Like, let me just go back to this one I did earlier. X to the 5th plus x squared. You could take out the smallest amount. The smallest amount is x cubed. So between a 1/3 and a negative 2/3, the small amount is the negative 2/3. Excuse me, so I could take out the x squared plus 4 to the negative 2/3. All right, so what's that going to leave me with? Well, remember, when you take something out, how do you figure out your new power? You just subtract. So to figure out my new power from this first guy, let's see here, I have x squared plus 4. Now I had a 1/3 power, but I took away a negative 2/3. So I had a 1/3, but I took away a negative 2/3. You just subtract. Well, that's going to actually end up being adding, and that's easy because 1/3 plus 2/3 is 1. So that's really nice. Minus 2/3 x squared, and then that's it, right? This whole thing got taken away. The whole x squared plus 4 negative 2/3 I factored out. So I get here, and then don't forget my denominator, right? Can't forget that denominator, x squared plus 4 raised to the 2/3. All right, now I'm going to continue to clean up here. I'm going to move over a line. Now again, I don't like negative exponents. I'm going to move them to the bottom. So check out what I have on top, by the way. On top, I don't even need these parentheses anymore. I have x squared plus 4 minus 2/3 x squared. So I have 1 x squared minus 2/3 x squared. So that's 1/3 x squared plus the 4. That's my numerator. And in the denominator, check this out. I have x squared plus 4 to the 4/3. Now, where did I get 4/3 from? Watch this, right? This guy has a negative exponent, so he's going to need to move to the bottom. So now I have x squared plus 4 to the 2/3, and I'm putting down there another x squared plus 4 to the 2/3. So I'd say now a grand total of x squared plus 4 to the 4/3. Again, just envision my denominator. I already had an x squared plus 4 to the 2/3. Now I'm going to go ahead and put down there another x squared plus 4 to the 2/3. And one of our exponent rules says, hey, when you got the same base, add the exponents. 2/3 and 2/3 is 4/3. So there is my final answer. Now, if you really don't like the double fraction right here with this 1/3, just multiply everything top and bottom by 3. So that's going to give you x squared plus 12 on top, and that's just going to give you a 3 times x squared plus 4 raised to the 4/3 on the bottom. So again, what do I want you to take away from this video? Well, I want you to take away the chain rule, but I want you to also appreciate that chain rule is actually not that hard. It's really not. It's all the cleanup work that comes in after the chain rule, product rule, quotient rule, power rule, you name it rule has been used. That cleanup work is simply algebra. It involves zero calculus. And that is what ends up being the trickiest part for most kids. So really take your time with that stuff, and hopefully the rest will become easier. The actual rule itself, trust me, will get easier with practice. And then you just got to work on that cleanup because that's what's going to be challenging. All right, guys, see you in the next video.